I'll quickly introduce what what Zoontenium is, what we do, and why we do what we do. In fact, we want to actually have you guys on board with matters to do with all the courses. So all the courses are actually on our learning management system. You can actually just go to zoontenium.com and access all our trainings because we will be posting every material on the learning management system. So you just go towards our portal, then towards, of course, if you haven't signed in, you'll need to first sign in, then you'll be able to access the course catalog. So from here, you'll be able to see the structure of the first phase, where we are having today an introduction and background check in this technology, what it is and what it's all about. Then, of course, later on, we shall continue adding more and more parts to it. And of course, if you're new here, please do join as a member. As a member, you can actually join through here, where you click here, become a citizen, and go to our page where you fill your data, and that will now register you as a member. In the future, we'll offer certificates for this particular course. So it's highly recommended that you do attend all the sessions and do actually participate in all the assessments that will be done, because through the assessments, that's how we'll actually gauge your knowledge and as well as your availability in actually attending all the sessions that we've been having. So I hope our speaker is here before we continue. Miss Stop screen sharing. Okay, so I see, yes, he's yet to join. And someone is asking, can you share the link? Yes, I can share the link. The link is actually on your, if you actually do this via Google Calendar, you can actually just go back to that section and then copy the link and share it to someone. But I'll as well share it here with you guys. And for the recordings, yes, I did say that the recordings will be posted as well as on our YouTube page. So don't worry about it. We'll also share the links later on. Yeah. I'd also love to acknowledge that after this session, we'll actually have an info session with regards to do with the PQC research that we're doing. So we rolled out our research paperwork that's uh, supposed to be submitted before 25th. That is exactly on the 18th of July. So we'll be tackling, to be specific, we'll be tackling PQC, and I think all the materials were actually shared with you if you're in the community. For those who have just joined today, please do join the community. The community on WhatsApp, uh, and actually be part of these discussions, because we'll actually be involving you guys in more and more R&D sessions, and as well as hackathons to quantathons to gauge you in all these things that are relevant to you. As we wait for the speaker, again, I'll be open with you that the research is one of the things that helps you get more rewards. And this session, we hope that members will actually come and present their paperworks as research. Either you've actually done a publication or implemented the publication, because normally these publications will actually progress towards incubation. So if you come and go beyond publication towards implementation, then you stand a chance to actually get incubation support, and as well as funding and startup advisory and mentorship. We do that a lot with startups. So in fact, at the end of this 24 weeks bootcamp, we hope that startups will come and actually contribute in incubation. So without further ado, I see the speaker is here. So I'll just quickly introduce him. We have Moan. Moan is a computer scientist, of course, with interest in quantum computing, and is from India. So today is going to be taking us through the introduction and background of quantum computing. So without further ado, I'll just uh, pass the mic to Moan, and you can as well screen share.
Hello.
Hello,
Hello.
hello, yeah. Go ahead. We can hear you. I think uh, you could as well just screen share. Are you able to screen share?
Yeah. Let me time sharing my screen.
Okay.
Actually, art is disturbable. My screen is not sharing. One sec, you are sitting. Art is disable. Attend the screen sharing. This pop-up message is showing.
Okay, let me
Hello.
help you with that. Let me help you with the screen sharing. I'll share the screen, and then you can progress with the presentation.
Yeah. Okay.
You're asking me? You're asking me? Oh,
Hello.
hey, you miss.
Okay, so I think the screen is visible. Can you all see my screen?
No, no, no. Your screen is not visible, sir.
Oh my, what have I been presenting then? Okay, let me screen it. Then let me share it again, once again. How about now?
Yeah, sir. Now visible.
Okay, perfect.
Good evening. Good evening to all. And my name is Kur. Yeah, sir. Can I continue?
Yes, please go ahead.
Yeah, okay. Good evening to all. And my name is Kuru Mohan. And today topic is the superposition. First of all, introduce the quantum technology. Like quantum technology, the nowadays we are both two technologies there. Like one is the classical system, one is the like a quantum computing. Why is the quantum technology importance means in classical system less security compared to this quantum technology. Like why? Because in in classical system only use the RSA algorithm and factorization this type of hello this type of algorithms using here. So but in quantum technology we are using the protocols source algorithm like different different algorithms you here using. That's why is the quantum technology high security. And sorry, screen is not visible. Hello. Yeah, okay. I will introduce you just what is our quantum technology. In quantum technology, here using the protocols, algorithms, and more. So first of all, here introduce the superposition. Like superposition means in classical system you only use the 0 or 1. But in superposition means at a time use the like a 0 or 1. At a time this shows like example means in by you can flip the one coin is the rotate the and in superposition it shows the at a time like head or tail. In okay now is the visible like imagine a spin is the coin before is the collapse. If you are the certain of whether it's a head or tail, but it's a take the being both similar in qubit, both 0 and 1. In the superposition is the for qubit mean they can be or arbitrary combination like a 0 and 1, such as the 40% and 60%. One is the more accurately. The state of qubit is the vector 2 Hilbert space describe the two complex number and alpha beta. It's a probability amplitude, and then they measure the qubit is a superposition collapse. The probability of amplitude determine the probability of measuring. The qubit is the either state a measurement made is the probability of finding the qubit state and 0 in Q1 and state 1 alpha. The sum of these probability must be have the always equal the 100. Like take the one example. In in classical system you can spin the one coin like so is the display the only 0 or 1 like a head or tail. But in quantum technology is the what is the main means superposition. It shows that at a time like head and tail at a time shows the visibly two sides. That is the main reason superposition. Yeah, next slide, sir. Yeah, inheritance means the secret of the state vector, the number of in vector and alpha beta are not just a probability, they are amplitude. Unlikely classical probabilities, which are the add the quantum amplitude can negative. Uh, like take the one example here. Like in quantum algorithm, use the inheritance to increase the chance and correct the answer, reduce the wrong answer. What is why here using the interference means like probability increase the like only correct answer find the in wrong answer they decrease the this type of wrong answers. Like example, like a water waves, and in water waves, two waves can be become the bigger or cancel each other. Like coming the two waves at a time the big, other neither they cancel the at a time the two waves. This is the interference. Next slide, sir. Yeah. Next is the quantum oracle. A quantum oracle means a black box of function is the each box check the input correct or wrong without revealing the like first is the what is the main motto is the check the your quantum oracle is the black box of function check the whether and input is the correct and answer revealing how it's work. Like many quantum algorithms like Gross algorithm and which something is the correct or yeah, this is the how it means like take the one example, like think like a teacher who's in class, he take the whole class, but some students says the correct answer, some students say the wrong answer, but teacher never tell answer like that. Like he predict the answer but never tell to future. Yeah, the oracle does not isolate it. It simply tag the state and any satisfies the rules. Yeah, okay, so next entanglement. Yeah, okay. First of all, entanglement means like in entanglement is the more connect the two or more qubits. This is the called entanglement, and two are if measure the one qubit or other instantly related. Like if they're 0 or 1. Okay. In entanglement means connect the 0 or 1. Why this entanglement is the most important means connect the portals, one portal to another portal. This is the pass the information like one place to another place. This is the secure by using E91 protocol. We pass the information safely by using E90 entanglement process. Like one qubit to another qubit, connect the each qubit. Like two or more qubits connect the or strongly connected. So a single state, they then entanglement qubit their lost individual identity. They mathematically describe the by one unified the wave function. Like what is the like one qubit means is the lost the and leave that qubit, connect the another qubit, like form the new connection. That's the one that line. Instant correlation means is the measure and manipulation, and one entanglement qubit instantly dedicate the state. It's a partner of regardless of physical distance. Yeah, yeah. Now we are everyone using the like transform the data one place to another place by using the E90 photons, like connect the one photon to another photon. Is entanglements more two or more like infinity of photons connect the pass information safely. The interface value. This is the foundation of unhackable quantum network, like by using the QKD, quantum key distribution, and complex and multivariable logics. Yeah, different logic by using the pass the data. Yeah. Next slide, sir. Qubit superposition. Yeah. Qubit can represent the more information that can classical bits. For example, two classical bits can represent the four possible states like 0 or 1, 1, 0, 1, 1, 0, and double 1. But in qubits, like a one qubit, two possible states. Here, like two qubits, four possible states, three qubits, eight possible states. That's the you can increase the qubits like possible states also like different ways also increases the number of possible states. The superposition state is clearly increased. Now let's consider 3, 4, 5 are generally number of qubits, but the number of states vector is increasing exponentially, and our space become the 8-dimensional, 16-dimensional, like 32 dimensional, are general 2 power and dimensionals. Like a more like number of possibilities there. Like passing the 300 qubits are present there. Next slide, sir. 300 qubits. Like yeah, okay. The magic of quantum computing is not just having 2 power 300 states. More than states, they are atoms in the observable universe. That is the how process the global supply chain, the matrix in a second rather than millions. But here is catch. To actually utilize the all dimensions, there are individual qubits. How they are able to interact with the another entanglement. Also here with computer can represent the all states. We cannot actually see, but we use the interface to find the right answer. Like example, it show the quantum computer. We are the so powerful. This much of larger than estimated the number of atoms. It observable universe. Yeah, in the extremely high. Next slide. Yeah, but this topic covering this such in holes was covering potentially did not catch it. Yeah, blow sphere means the blow sphere is a 3D is a 3D sphere that is the geometrically representation of the pure state of 2D complex. Is a space is that describe the single qubit. It's a possible state or the point is surface. The north and south pole are spare corresponding in the alpha 0 and 1 states are respectively all point all other points are the surface. Our sphere represents the superposition state, which are the linear combination of the 0 and 1 state by representing the quantum state as point is this sphere. It is a possible visualize the effects and the quantum operation on these states. Slide is not visible. Yeah, next slide, sir. Hey, slides about visible outlier. Yeah, okay. Take Q mode. Core unit is the continuous variable. Quantum computing (CVQC) means is the instant of process is the reading and zeros and ones information is the encoding into continue property of like codons. Like here take the one here take the like encryption method. We like pass the information by using the encryption method. Here using the encryption 256 bits and decryption. So zeros and ones is the communication process most important. So we are using the here is zeros ones by using the photons. Like data pass the one source to another source. Most important is this communication system like encoding and decoding properties. These strategies are enterprise advantage, cost and infrastructure. Like often is the like if you want maintain this quantum technology, you need to and certain room temperature is the maintenance like elements, massive security, refrigeration costs. Here, this is the high to maintain this quantum technology. Telecom integration means yeah, negatively with the world existing the fiber optical network and QKD network. Like here using a fiber cables means is the pass the data is the more but safe and securely. Like AI acceleration means inherently designed for the continuous mathematic powering machine learning and neural network. Okay. Sir, next slide. నేనేం కనిపించను కానీ దీంట్లో Like hi, okay. The master plan is the quantum algorithms. In classical okay. Finally, then a circuit is a designed to solve the specific problems like finding the or simultaneously a new medicine to become the quantum algorithm. The ultimate goal is the delivering the business solution through the like what is the quantum algorithm means like in classical system store the only zero or one. Like now explain the clearly like what is the algorithm that type of okay. Is the first section is the only I'm introduce only section. Now I explain clearly okay. Yeah, a class computer is to, data stored the only zero or one. That's the classical system. Coming to in quantum computing, here stored the like superposition. Like recently I said na, that one superposition like zeros one store here. That is called superposition. In quantum algorithm, use the quantum properties to solve the like certain problems much. Then classical algorithm. Okay, next slide. This yeah. In classical system store the only like zeros and ones, but in coming to in quantum technology store the like uh, at a time store the heavy data because here using the Hadamard gate. Hadamard gate means like a zeros one store the at a time. Yeah, I feel so stupid. Idiot. My God, yeah. Sir, next slide. Eight minutes. Summary. Like a qubit is the fundamental process. As said, the exponential greater is the potential that binary bits are due to the it is the core feature of superposition. A single qubit gate provides the primary logic block. It's a sir, slide is not visible properly, sir. Continue. Okay, now continue. A single qubit gate is provide the primary logic building block for the previous state, the manipulation, including the flip and flipping state and space. Multi-qubit means like enable the system level cooperation, linking multiple qubits through the entanglement. The processing power. The quantum circuit create the required system to complete the quantum computation. The ultimate among the industrial like paramedic is the logistics and finance. So multi-qubit gates together and circuit organization to execute the complex algorithms. That
The recording has stopped.
All right. So I would want to ask, is that over from Mon?
this is a complete section.
Okay. Okay, thank you. Thank you so much. Thank you so much for taking us through that. Yes, that's the first part where I think I'll share the slides with all of us, and you'll be able to access them on our portal as well. So I hope that we do look up the slides later on. I hear people saying that the voice wasn't clear. Okay,